Welcome, ladies and gentlemen. This is section 6.2 of Mrs. Quinn's geometry class. And today we're going to talk about isosceles triangles. If you look at that picture on the video of triangle ABC, your vertex angle is always angle A. Your base right here is CB. And so your base angles are angles B and angle C. Notice that for an isosceles triangle, you have at least two side lengths that are equal. So I'm going to call it my base angles angle C and angle B. Those are the angles below the congruent side lengths. The angle A, the vertex angle, is always connected or formed by the two congruent side lengths. All right, then we have the triangle symmetry theorem. A line containing the bisector of the vertex angle of an isosceles triangle is the symmetry line for the triangle. Now let's see what that means. If this is my angle A, or my vertex angle, if I have a line that is the bisector of the vertex angle, that means it being a symmetry line means that it's the perpendicular bisector of my base. Does everybody agree with that? We know that our line of symmetry is synonymous with being the perpendicular bisector. All right, and then we also have the isosceles triangle coincidence theorem. And in an isosceles triangle, the bisector of the vertex angle, the perpendicular bisector of the base, and the median all determine the same line. If you don't know that word median, your median is the line through the vertex and the midpoint of the base. That just means for me that anything that chops my angle in half is going to chop my base in half, and then these three things are all the same line. The isosceles triangle base angles theorem. If a triangle has two congruent sides, then the angles opposite them are congruent. So basically, if my side lengths are congruent, then the angles opposite those congruent lengths also have to be equal, which we'll talk more about in a moment. Again, notice your vertex angle is connected to these two congruent side lengths. For an example problem, if I have an isosceles triangle where I know the vertex angle is 24 degrees and I want to find the measure of the other two angles, since they are opposite these two congruent side lengths, I know they must be equal. So I'm going to take 180 and minus 24, and what do I get? Well, hopefully you'll agree with me that I get 156. And then when I divide 156 by 2, that is going to equal the value of both angle 2 and angle 3. And it looks to me like 2 will go in here 78 times, which means that these angles are 78 degrees. All right? Now let's see if we know one of our base angles. If I know that this angle is 65, the measure of angle 2 automatically has to be 65. And if I add those together, hopefully you'll agree with me that I get 130 degrees. So I'm going to take 180 and minus 130, and I get 50 degrees left over for the measure of angle 1. All right. Equilateral triangle symmetry theorem. Every equilateral triangle has three lines of symmetry, which are the bisectors of its angles. If I have an equilateral triangle, we know that each angle must equal 60, so that our total is 180. What we're saying here is that we have a line of symmetry here, here, and here, and all of those are bisectors of our angles. To be equiangular means that all the angles have the same measure, and so we know for an equilateral triangle theorem that if a triangle is equilateral, then it has to be equiangular. So if your lengths are the same, the angles opposite them also have to be the same. The corollary is that each angle, sorry, I can't spell, in an equilateral triangle has a measure of 60 degrees. All right, for tomorrow, I would like you to attempt this little proof right here. You're given AD and BC intersect at point C. You want to prove that the measure of angle ABC is equal to the measure of angle ECD. Now, I'm going to give you some hints. First, you're going to start off with what you're given, and then you're going to think about what kind of triangle ABC is. Notice that these two side lengths are the same. So what do you automatically know about these two angles right here? Well, they're base angles, thus they would have to be what? All right, hopefully you're thinking the right word in your head. And then these angles are what kind of angles? It starts with a V. Hopefully you're thinking vertical angles, so you know something about these angles. So start off by saying something about these angles, and then end up with a statement that tells me something about these two angles. All right, give it a shot, and I will see you tomorrow.